Right, plan for the recording is to talk through the review answer key. So let's get rolling. So chapter 5, a bunch of integrals. First page is all algebraic. So we're going to find antiderivatives and use the fundamental theorem of calculus when we're finding the definite integral. So question 1, I'm going to use my power rule. So I'm simply going to add 1 to the exponent, divide the old coefficient by the new exponent. And so this becomes x raised to the 5th power. Dividing the coefficient of 1 by 5, and I get 1/5 x to the 5th. Same idea here. We're going to add 1 to the exponent. Excuse me. And I get a 4. We're going to divide the 1 by 4, and I get 1/4. And same for the next one. Add 1 and I get a 3. Divide by 1, or divide by the 1 by 3, and then I don't forget my plus c. Okay, hopefully that was really easy. Okay, next one, exactly the same concept. Add 1 to a -2, I get -1. Divide 3 by -1, and I get -3. Add 1 to a -3, and I get a -2. Divide a -4 by -2, and I get a +2 plus c. Okay, good so far. I'm going to rewrite before I integrate. So I'm going to rewrite this as 4/3, taking the fraction out as a coefficient. And then this is 1/t², which as an exponent is t to the -2. Exact same logic for the next one. And this is t to the -1. And I do need a parentheses around that, just like we have in the original problem. And it's all with respect to t. Okay, exact same thing. Add 1 to the exponent, I get -1. Divide 4/3 by -1, and I get -4/3 t to the -1st power. I can't do that here because I have a -1 exponent. And so if we remember right, this is the same thing as 1/t, which is my natural logarithm. So this becomes 7/2 natural log of the absolute value of t. Sorry, that's a t. It makes it smaller. Whoops, wrong button. Okay. Over here, I'm going to simplify first. So I'm going to divide every term in the top by the 2x in the bottom. And so this becomes 3/2. X² divided by x is just x. 4 divided by 2 is 2, and the x divided by x is just 1. So technically it's 2 times 1, which is just 2. And the same logic as we used over here, I'm going to write this as 1/2x, which is 1/2 x to the -1st power. Just like the other one, this needs a parentheses because we are integrating the whole entire mess with respect to x. Once again, I got power rule. Add 1 to 2, add 1 to 1, and I get 2. Divide 3/2 by 2. Remember, dividing by 2 is the same thing as multiplying by 1/2. So this becomes 3/4 x² plus 2x. Same logic as what we used right here. X to -1 is the same thing as 1/x, whose integral, or which the integral is ln x. And I need my absolute value. And I need my plus c. All right, we're cruising. Question 5. Just integrate each one separately. The derivative of cosine is a negative sign, so this needs to be a -2 cosine x. The derivative of sine is a positive cosine, so that just needs to be sine. And the constants or the coefficients just come along for the ride. All right, this is my inverse tangent. I'm using the 1/a. I derived it on the paper, so I'm going to talk through the formula because the formula is quite a bit easier if you can memorize it. 1/a tangent of u over a. Okay, so here's my formula. This 4 needs to go away, so I'm just going to put it out in front. I should write this. The integral of 1 over a squared plus u squared du. That's where this becomes this. Okay, so I had to have a 1 on top, so I have to get rid of that 4. In case you're wondering, why did I have to get rid of the 4? Okay, this is 1 over a squared. Well, what number squared is 9? 3. So my a is 3. Plus u squared, and so my u is just x. Okay, and now I'm going to plug in. So it says 1 over a, but I already have this 4, so it becomes 4 over a, and a was 3, so it's 4/3. Arctangent of u, which is x, over a, which is 3, plus c. And I did the derivation on the board yesterday, so I'm not going to go ahead and talk through that one. But if you can memorize this formula, quite a bit easier. Okay. U substitution. I'm going to call my u the inside function. So I'm going to call u equal to 5x squared minus 4. So derivative of that is du over dx, or du equals 10x times dx. Well, I have an 8 dx, so I'm just going to look at the x. I want to get rid of the 10. So I have 1/10 du equals x dx. Okay, so the x dx is going to go away. The 5x squared minus 4 is going to go away, and I have an 8 left. That's okay. I'm going to put the 8 out in front. Integral x dx is 1/10 du, and my integral is the square root of u. So I'm just going to take that 8/10 and put it in front. This becomes u to the 1/2. Add 1 to the exponent, I get 3/2. Divide the old coefficient by the new exponent. And I'm just going to leave that 1/10 alone. I'm not thinking about that when I did that process. And technically, you can leave it right there. Well, that's not true. I have to put the u back in. I don't have to multiply these together, but I do have to put the u in. So if I multiplied them together, I'm going to cancel this 2 with this 10. I get 5. And 8 times 1 is 8. 3 times 5 is 15. That's where my 8/15ths come from. And I'm going to put that u back in. If you want to write it as an exponent, that's totally fine. You can write it as 5x squared minus 4 raised to the 3/2 power. If you see it as multiple choice, though, you should recognize that is the same thing as what I had on the answer key. It is the square root of 5x squared minus 4, and the whole thing being raised to the 3rd power. I can put that whole thing inside, or I can put it outside. And on the answer key, I chose to put it outside, so that's how I'll write this. But you could have also put a parentheses right here and put the cube on the inside also. And don't forget your plus c. Okay. Already done this concept several times. I'm going to divide the coefficient just like I did here. Divide each one of these by the denominator. I will divide each one of these by the denominator. When you divide, you subtract exponents, so the 4 gets left alone. This is x to the 1st power. 1 minus 1/2 is just 1/2. And this becomes 5x to the negative 1/2. Okay, I have not done anything yet except for, let me rephrase that. I have not done anything with the integral yet. I just simplified my fraction. And now we do power rule. Add 1 to the exponent, divide the old coefficient by the new exponent, and so on. So this, notice, is exactly the same thing. So I'm going to get this integral of that. And so 4 times 2/3 is 8/3. Add 1 and I get 3/2. Okay, add 1 to the exponent, I get 3/2. Divide 4 by 3/2. When you divide by a fraction, you multiply by the reciprocal, in case you're wondering how I got 8/3. Okay, Add 1 to negative 1/2, I get a positive 1/2. 5 divided by half is the same thing as 5 times 2. I get 10, and I get my plus c. Okay. If you did not see this on the answer key, or if you saw it and didn't know what I did, this is my Pythagorean theorem in terms of trig functions. Remember, sine squared plus cosine squared equals 1. So 1 minus sine squared is exactly the same thing as cosine squared. So I'm going to take out the 1 minus sine squared and write cosine squared divided by cosine squared. Cosine squared over cosine squared is just 1, and so this becomes the integral of 1. And the derivative of 1 is just x, evaluated from 0 to pi over 4, which becomes pi over 4 minus 0, which is just pi over 4. Okay, integrate each one separately. Add 1 to 1, I get 2. 2 divided by 2 is 1, and I get x squared. This one is my natural log. No fraction, no coefficient, just a natural log. I don't need a plus c because I have an upper-lower bound. I need to use the fundamental theorem of calculus. Plug in e, and this becomes e squared. Plug in e, and I get ln of 1. Sorry, I get the ln of e. There's upper bound. Plug in 1. There's plugging in the lower bound, and evaluate it. Ln of e is 1. Ln of 1 is 0. Combine like terms. 1 minus 1 is equal to 0, and my final answer is e squared. Number 11. Typically in a fraction, if I need to do a u substitution, the u will come or will represent the bottom. So let's do that, and let's see what happens. So my denominator is 4 minus x. Derivative becomes du equals a negative 1 dx. Well, I just have a regular old dx here, not a negative, so I'm going to get rid of that negative sign. All right, now I have a substitution for this, and I have a substitution for this, but I have a problem. I have this x here. Well, one of the techniques we can use is rewriting this expression for x so that I can substitute something for x that's in terms of u. So I'm going to add x to this side and subtract u from this side, and so x equals, excuse me, 4 minus u. Now I have a substitution. Integral of 2 plus x, but I'm going to take x out, put 4 minus u in its place. All over u. Dx comes out, a negative du goes in its place. This 0 is an x, but now these are all u's. So let's change. Put in the 0 for x, and I get u equals 4. Put in the 3 for x, and I get u equals 1. I'm going to rearrange a little bit. 2 plus 4 is 6. Take that negative and put it in front. But I'm also going to flip this sign. So this becomes 1 to 4. And so I put a negative here. But I already bring in this negative here. So the negative and the negative from switching makes it a positive. Remember, like we did before, I have a fraction where there's one term on the bottom and there's 2 on top. So now I'm going to integrate each, or I'm going to split that into 2 fractions and then integrate. This becomes 6 times 1 over u. I wrote it that way just to make it easier for you to see. Integrate. Integral of 1 over u is just ln. But it's 6 ln, sorry. And integral of 1 is just u. And that whole thing is evaluated from 1 to 4. Okay, I'm going to slide over here because there's no room. So I have 6 ln 4 minus 4, plugging in the upper bound into both of my u's. Take that answer and subtract. Plug in 1, 6 ln of 1 minus 1. Work it out. Ln of 4, I don't know. So I'm going to leave it alone. Ln of 1 I do know is 0. And then I have 0 minus 1, which is a negative 1. So this whole entire answer over here is a negative 1. And now I have a negative 4 minus a minus 1, which is a negative 4 plus 1, which is a negative 3. Okay. Number 12. Remember, if we have an inside-outside function, if we have a chain rule concept, I'm going to make a u substitution, and my u will typically be the inside function. So the inside of a square is sine, and the derivative of sine is cosine. And that works out nice because that's my other function. Cosine x dx, cosine x dx. That can go out, du can go in its place. This can come out, and u can go in its place. So we're sitting pretty good. We have an integral of u squared du. I'm going to change. I'm going to plug in, these are x's. I want them in terms of u. So I'm going to take the pi over 6 and put it right here. Sine of pi over 6 is a half. Plug in pi over 2. Sine of pi over 2 is 1. Now integrate. Integral of u squared is 1/3 u cubed. Evaluated from 1/2 to 1. I'm going to leave the 1/3 alone. I'm going to plug in the upper bound. Plugging in 1 gives me 1. Plugging in a half gives me 1/2 cubed, or 1/8. 1/8. 1 minus 1/8 is 7/8. Because I have 8/8 minus 7/8 is 1/8. Multiply, and I get 7/24. I got it. All right, number 13. Derivative of an integral. Here's my rule. I take the upper bound and I plug it in for x, or plug it in for t in this case. Leave everything else alone. Multiply by the derivative of the upper bound. Do a little combining, and I get f of x equals the square root of 15x minus 6 times 5. I'm going to stick that 5 in a better spot, or put it right here. Okay. When you take the derivative of an integral, if the top is something other than just plain old x, then you can plug it in as is and then multiply by its derivative. The bottom has to be a constant in order to do that. Okay. Particular solution. So I have two options. Well, we'll just go with one option. I'm going to integrate a prime to find the original function. To go backwards, I'm going to integrate. So I want the integral of 3x squared minus 2x. Integrating that gives me x cubed minus x squared. That was kind of nice. Plus c. Now, if this was f prime, then this is f of x. So technically this is equal to f of x. But I need that c because it's a particular solution, not a general solution. So I'm going to plug in the 1 for x in both places. I'm going to plug in the 4 for y because this is my initial condition, and I'm going to solve for c. 1 cubed is 1, minus 1 squared is 0, plus c, so c equals 4. Go back to my equation, and I have f of x equals x cubed minus x squared plus 4. General solution with the plus c. Particular solution is when you solve for c. Okay, we have a particle moving along the x-axis. It's given velocity, or this graph is its given velocity. And the position we know at time equals 2, the position is a -5. Okay, so there's our setup. Question is at time equals 0, the particle traveling left or right? Left or right meaning is my velocity positive or negative? So at time equal 4, no, at time equals 0, my velocity is a -4. The actual y value for my function is a -4, and this function is velocity. So v of 0 equals a -4, which is less than 0, which means we're going left. I wrote it out better on my answer key. Since v of 0 is less than 0, the particle is traveling left. Position of the particle at time equals 10. I don't know position. I know velocity. How do I get from position to velocity? We integrate. So my change in position will be the integral of some number to some number. So where do I want to integrate? I want to integrate from what I know to where I want to be. So I'm integrating from time equal 2, because I know the time, I know the position at time equal 2, to time equals 10. And what I'm integrating is my velocity equation. So this tells me, super important, this tells me the change in position from time equals 2 to time equals 8. The integral of velocity is position. So the integral of velocity when I have an upper and lower bound is the change in position. So I know where the particle is at time equal 2. It's a -5. And to that, I'm going to add the change in position between time equals 2 to time equals 10. Okay, I think I explained that enough. In order to find the integral on a graph, it's the area between the curve and the x-axis from 2 to 10. So what I did is I divided it into a triangle right here, and this area is 2. I divided it into another triangle right here, and this area is 2. And this, you can just count the squares. Looks like there's 8 to me. So -2, +2 goes away, and so this integral is 8. So my change in position is 8. I started from 5. We moved to the right 8 because it's a positive change, and we're at the position of 3. Same logic. Position of the particle at time equals 0. I'm going to integrate from what I know to where I want to end up, and I'm going to add that to where I started. Problem here is lower bound needs to be bigger than the upper bound. So I'm going to switch, and this becomes a negative, and I'm going to go from 0 to 2. Area between the curve and the x-axis from 0 to 2. From 0 to 2 looks like, 0 to 2 looks like 6. 1/2, we can do it two ways. We can say this area right here, this triangle, is 1/2 of 2 times 2, which is 2. And this is 4, so this area right here is 6. You could also do trap rule. 1/2 height times base 1 plus base 2. Either way, this comes out to be 6. It is below the x-axis, so it's a -6. So we get a -5 minus a -6, or a -5 plus 6, which is 1. Okay. When does a particle change directions? Particle changes directions when the velocity changes sign. This is my velocity graph. So this one's pretty easy. Look at the graph. Where does it pass through the x-axis? At time equals 4. Okay. Last one. What is the distance traveled? Now I don't care if we're going left or right. Everything below the x-axis represents moving left. Everything above the x-axis represents moving right. But I don't care if we're moving left or right. I just want to know how far are we moving. So this area underneath the x-axis is 1/2 base times height. 4 times 4 is 16. Half of 16 is 8. Area underneath the x-axis is 8, and it is negative, but I just want the distance is 8. Whether we're moving left or right, don't care. This one we already did was 10. Add them all up, and we get 18, whatever, units, feet, miles, whatever. Okay. Question 16. Here's what I won't say always do it, but almost always. If I know a function is defined in terms of a integral, I'm going to take the derivative of that to find out what the derivative is. And the derivative of an integral is you take the upper bound and you plug it in. So f prime of x is equal to h of x times the derivative of the upper bound, which is just 1. So it's just f of x. Sorry, h of x. So f prime is equal to h. F double prime then, because I may need that. Okay, I know I need that. So f double prime is equal to h prime. And I usually will start my question like that. Okay, now this helps me to just not have to think about the relationship of f to f prime to h to all that stuff. Now I can just answer the question. At what values of x will f have a possible relative max? Go back to chapter 4. When do relative maximums occur? When my derivative of f, okay, when will f, so when my derivative is equal to 0, which means since f prime is equal to h, this is when h is equal to 0. Where is h equal to 0? At 4 and at 8. Same chapter 4. My derivative goes from positive, h goes from positive to negative, so my function goes from increasing to decreasing. T equals 4 is the max. Or in this case, x equals 4 is the max. Let's check the other one, because it says at what values. And the other one, it goes from decreasing to increasing, then this one must be a min. So I'm only going to write the maximum. And I would explain, if it asked me to justify, I would use first derivative test. By first derivative test, since my function goes from increasing to decreasing at time equals 4, the particle has a maximum at that point in time. I guess it's not a particle. I don't know what this is. My function has a maximum. Okay, points of inflection. Where's my second derivative equal to 0 or undefined? Second derivative is h prime. Right? We just said that up here. So second derivative of f is h prime. So there's where it's equal to 0. Points of inflection occur where my second derivative is 0, undefined, and where it switches signs. Does my second derivative switch signs? Yep. So x equals 0, x equals 5 is a point of inflection. Why? Because its second derivative is 0 and its second derivative switches signs. Number 17. Water flowing into the tank at a continuous rate. The rate is given in the table. Use the following methods. 4 subintervals. So I have one subinterval from 0 to 1. I have one subinterval from 1 to 2, from 2 to 3, and from 3 to 4. That's what that little notation above my table is on my answer key. Okay, so there's my 4 subintervals. Picture this as a rectangle. Left Riemann sum says look to the left-hand side to get your height. So there's my height. The width of my rectangle from 0 to 1 is 1. The height of my rectangle is 20, so the area is length times width. Plus, next rectangle has a base or a width of 1. Left Riemann sum has a height of 25. Next interval has a width of 1 and a height of 23. Next one from 3 to 4 has a width of 1 and a height of 30. Multiplying all that out, adding it all together, we get 98. Since this is a constant width, you could say 20 plus 25 plus 23 plus 30 times by 1. If this was a 2, you could do it times by 2 and so on. If these had been different widths, you'd have to do what I did here and individually write them out. Okay, right Riemann sum, same idea, my same rectangles, but now this is the right side of my interval. So again, the width is 1, the height is 25. We already know the width is the same, so I'm just going to go 25 plus 23, 3 plus 30 plus 28. My right Riemann sum, there's 1 to the right, there's to the right, there's to the right, and there's to the right. Notice on the left, you'll not use the last number on the right, and on the right, you'll not use the first number on the left. Okay, adding all those up, timesing it by 1 gives me 106. What are my units? Super important, because most of the time they ask you, what does it represent? So 98 gallons flowed out of the tank during those 4 minutes, or in this case, 106 gallons flowed out of the tank in those 4 minutes. Okay, number 18. Laser pointer moves back and forth along a fixed x-axis, is given velocity, is that equation. At time equal 1, the printer's position. So we know that x of 1 equals 4. Position of the printer. I know the position at 1. I want to know the position at 4. So I'm going to integrate my velocity from time equal 1 to time equal 4. Then I'm going to add that to where I started. Start at 4, we're going to add the change, and we'll know where we end up. Grab a calculator, type that mess in, and you should get the answer that's on. I probably could do that. All right, I paused for a second. That's why also I jumped in. I want to get my calculator up and running. All right, so here's my calculator. I'm going to, since I look and I can see on the letter B, I need to use it again. I'm just going to plug that in real quick. I'm going to go t minus, or in this case, the square root of, second square root of x minus 1, jump over, cosine squared, or cosine, sorry, of x squared, jump over, get out of here, or not get out of here, store that as v of x. Make sure I have it before I get out. X minus 1 square root. All right. Now I'm going to go to menu. I'm going to go to calculus and numerical integral. I'm going to integrate from 1 to 4. And my integral is of v of x. Jump over here, dx. And I probably should have put it like we had it on the, whoops, like we have it on the worksheet and have it 4 plus, but when it's addition, it doesn't matter. And I get 3.720, etc. Remember, we want 3 decimal places, so it's 3.72. 0. Don't forget the 0. Don't write 3.72. 3.720. Okay? If you write it as 3.72, then you've rounded to the nearest hundredth, not thousandths. You have to have the 0 there to show the thousandths place value. Can't assume that it's a 0 if you don't write it. Okay. Find the total distance traveled. Total distance traveled, I don't care where I start now, but I don't care if I'm going left or right either. So now I'm going to integrate the absolute value of velocity in order to find my integral. So I'm going to integrate, same, menu, number 4, calculus, number 2, I think yours is number 4 on yours, it's an integral. On mine, it's numerical integral. Integrating from 1 to 4. In case the bell rings while I'm talking, sorry. I'm going to go here, and I want absolute value, so I go over there, and I type in v of x. And if you did not store it, you would just type the equation in right there. And I'm doing this in terms of x. Answer 2.1987, etc. So the 8 gets rounded to a 9. Okay. I gotta hit pause because the bell's gonna ring, but you won't notice I hit pause. Okay, question 19. When you do these FRQs, it's super important that we recognize what the graph is giving you, what the table is giving you. I know that seems obvious, but it really, really is important to know what does my data represent. So in this case, my data represents number of people. Okay, so as we look to this table, we have number of people, and sorry, I had to pause. Mr. Fry walked in on me. All right, so we have our table represents number of people and hours. So as we read this, just recognize number of people. Okay, concert tickets on sale at noon, sold out in 9 hours. Number of people waiting in line is given by the table, and from 0 to 9 hours. Okay, use the data to estimate the rate. Okay, so I'm given number and I want rate, so I'm thinking probably slope. The rate at which the number of people waiting in line has changed at time equal, or is changing at time equals 5:30. Well, there is no 5:30, so we're going to have to do the average rate of change and use kind of the mean value theorem and saying at some point in time, there's the average rate of change is equal to the instantaneous. It's kind of that idea. So I want a point in between here. So I'm going to have to take the average on the endpoints. So I'm going to do 150. So L of 7 minus L of 4. I'm going to bracket the point I need, or the time I need, divided by 7 minus 4. So L of 7 is 150. L of 4 is 126. 7 minus 4 is 3. And I get 24 divided by 3, which is 8. Okay, so it says indicate units of measure. And so 8 on top is people, on bottom is hour. So it's 8 people per 1 hour. And you don't have to have that 1. 8 people per hour. Okay, letter B. Use trapezoidal sums. So 1/2 height times base 1 plus base 2. We have 3 sub-intervals. So now you have to visualize 3 trapezoids in there. And if you don't like that, make a picture. Okay, so you could draw a graph, and you could plot your points, and you could actually draw out your 3 trapezoids. That might help. But here's my 3. I have 1, 2, 3. 3 trapezoids. My base of the first one is 3, second one is 4, third one is 2. Okay, so trapezoid, 1/2 height. And like I said, my first one is 3 times base 1, which is 120, plus base 2, which is 176. Oh, wait a minute, I'm not going... Never mind. I'm only going to 4. Ignore what I just said. Hopefully you caught that. You're probably wondering, what are you doing? Okay, going to 4. So I have 1, 2, 3. So try that again. 1/2 height, which is 1, times base 1, which is 120, plus base 2, which is 156. Plus 1/2 times height, which in this case is 2. The distance from 1 to 3, that's my height, times base 1, which is 156, plus base 2, which is 176, plus 1/2 height, which in this case is 1, times base 1, which is 176, plus base 2, which is 1 26. Work all that out. Grab your calculator, type it in, and you get 155.25. What are we finding? Use a trapezoidal sum to estimate the average number of people. 155.25 people. Technically, you can't have 0.25 people, but statistically, you can. So we leave the 0.25 in there. And it's not, you could put 1,000.02 or a 155.250, but really that zero means that we rounded, and this wasn't a rounding. So you, and I know last time we said I needed it, but this time it actually cuts off at 0.25. There is no zero, so you don't have to have that. If you put it there, it's not wrong, but you don't have to have it. Okay. What is the fewest number of times at which the derivative, L prime, must equal 0? When I see that, I am thinking intermediate value theorem. When is my derivative going to be 0? So L prime needs to be 0. Intermediate value theorem says it switches signs. So in order for my derivative to be to 0, it has to be positive on one side, negative on the other side, or vice versa. And if that happens, there must be a 0 somewhere here. Well, I don't have a derivative. So how do I know if my derivative is 0? Is positive? My values are increasing. So the number of people in line is increasing until I get to 3. My derivative is positive everywhere from 0 to 3. My derivative now is negative from 3 to 4 because the number of people in line is decreasing. So the rate at which people come into the line is negative. And then again it's positive, and then again it's negative. So it's positive, it's negative, it's positive, it's negative. So how many times? 1, 2, 3. It changes sign 3 times. What is the fewest number of times? 3. Give reason for your answer, and I would say, you can read what AP folks said, but I would say L of t, increases from 0 to 3, implying L prime is positive. L of t, wow, that's an L. L of t, wow, I did it again, sorry. L of t decreases from 3 to 4, implying L prime is negative, and so on. After you write all the rest, by intermediate value theorem, there are 3 places where it must be 0. Okay? All right. And you can read the AP folks' description. It's obviously really good. Okay, question D. The rate at which tickets were sold is modeled by that equation. Based on the model, how many tickets? So how do you go from rate to number? You integrate. So I'm going to integrate this thing from 0 to 3. And I'm going to integrate my R of t, and I would type that equation in. In this case, the number of tickets at time equals 0 is 0, so I'm not going to add anything because there was no initial amount sold. I just integrate that from 0 to 3. And the answer is 972. And I just did one on the calculator, so I'm assuming you can do that. And then this, again, this is number of tickets sold, so I can't have a decimal number of tickets sold. That we do know. So it's 973 tickets. Rounding up, approximately 973 tickets. Okay, number 20. Particle moving along the x-axis, velocity. I'm given velocity. Last time we were given amount, now we're given a rate. The velocity at time equals 0, 3, and 5 is 0, which is what it looks like. They're just verifying or clarifying. And it looks like we have horizontal tangents, and they are just saying, yep, there's horizontal tangents at 1 and at 4. Areas of regions bounded from 0 to 3 is 8. From 3 to 5 is 3. And from 0 to 6 is 2. So this region is 2. Okay, these are negative, and that one's positive. All right, find both the time and the position of the particle when it's furthest left and justify. So what do they know? At time equals 0, so x of 0 equals -2. My particle starts to travel. At time equals 3, x of 3, my particle switches direction. And the particle at that point in time is -10 because it's going 8 more units to the left. And what was the question? At 6. And I know that h or x of 5, now it's moving right, so it's at -7. And then at 6, we're going another 2 units, so it's a -9. So I would say by extreme value theorem, it has to be at x equals 3. I would say at x equals 3, the particle is at -10 by extreme value theorem. This is a absolute min, or furthest left. Whoops. If we look at their description, their explanation, they use this fancy word. No, sorry, that's in part B. Never mind. I'll get to it when I get to B. That's what I would say. They use some other reasoning, but I think this works also just as well. Or you can use what they said also, but you can read what they said. Okay. Question B. For how many values is the particle at x equals -8? I would use exact same points I used earlier. Wow, excuse me. At x equals 0, it's a -2. At x equals 3, it equals a -10. At x equals 5, it equals a -7. And x equals 6, we're at a -9. Going back up, what do we need in order to use the intermediate value theorem? It must be continuous, right? So how do I know this thing is continuous? Well, since it's differentiable, my velocity exists everywhere, my position, since x of t is differentiable in 0 to 6, that implies continuous. Thus, by intermediate value theorem, there must be a time 3 times when x of t equals -8. 1, 2, 3. -8 is between these two, and between these two. Since it's x of t is differentiable, x of t is continuous. Okay, what they use. So what they said is The particle moves continuously and monotonically. That just means in the same pattern, it doesn't change, meaning it has always is increasing in that interval, or it's always decreasing in that interval. It changes at the same rate, monotonically, not changing. Like monotone has the same tone. Okay, sorry, that was my attempt at that. So it has the same rate from 0 to 3, from 3 to 5, and so on. That works also. Again, what I said is what I thought of, so obviously that's what I like. But you can use what they said also. Letter C. On what interval is the speed, on that interval is the speed increasing or decreasing? Remember speed. If acceleration and velocity have the same sign, speed is increasing. If acceleration and velocity have different signs, the speed is decreasing. From 2 to 3. From 2 to 3, my particle's velocity is below the x-axis, so it's negative. The velocity is increasing, so acceleration is positive. So what I would say is, since v of t is less than 0 and a of t is greater than 0 in or from t equals t greater than 2 to 3, the speed is decreasing. Since v of t and a of t signs are different. Okay, so I said it here. I just wanted to make sure that whoever's reading it knew that I knew it's because their signs are different. That's why the speed is decreasing. Yeah, good. Letter D. During what time intervals is, if any, the acceleration of the particle negative? Justify your answer. Where's my acceleration negative? Where my velocity is decreasing. Velocity is decreasing from 0 to 1 and from 4 to 6. I would say from 0 to 4, no, 0 to 1. I probably should use a T. Sorry, I'm trying to write on my Wacom tablet. It's not working very good. From time equals 0 to time equal 1, and from time equal 4 to time equals 6. Velocity is decreasing, which implies acceleration is negative. Yeah, that's all I'd write. Okay, that's it. Hope that helps. See if I can find my off button.